Hello everybody. Today I can prove lines are parallel by using CPCTC to show that alternate interior, alternate exterior, or corresponding angles are congruent. This is actually a very important lesson, not only here, but when we come back to proofs later on in the year. For the commonly asked 6-point Regents questions, you're going to have to prove lines are parallel. So for that reason as well, this is a very important lesson. So we know what to do when we're told that lines are parallel. If we know that these lines are parallel, we know that we can conclude that alternate exterior angles are congruent. We can conclude that alternate interior angles are congruent. And we can conclude that corresponding angles are congruent. Well, it works the other way as well. If I have alternate exterior angles congruent, then I can conclude that the lines are parallel. If I have alternate interior angles congruent, I can conclude that the lines are parallel. If I have corresponding angles congruent, I can conclude that the lines are parallel. So in order to prove lines are parallel, I need to show that either alternate interior angles are congruent, alternate exterior angles are congruent, or corresponding angles are congruent. This lesson is just the mini proofs version of it, and then later on we'll integrate this into a full proof. So what we're doing here, we're starting with the triangles are congruent, but in a regular proof you'll have to first prove the triangles are congruent. That's not the objective of this right now. The objective is understanding how to prove the lines are parallel. So we got statements, we've got reasons. We'll just start with the triangles being congruent, and we'll say given. So in order to prove the lines are parallel, I need either alternate interior, alternate exterior, or corresponding angles to be congruent. Since these triangles are the same, I can use CPCTC to state any corresponding side or angle I want. So since these triangles are the same, by CPCTC, I can state that angle R is congruent to angle Y. Now, since angle R and angle Y are alternate interior angles, if the alternate interior angles are congruent, that makes the lines parallel. So I can state that MY is parallel to RE, and it's the same reason as the other direction. Parallel lines cut by a transversal form congruent, and they are both inside, so that is alternate interior angles. In order to state that lines are parallel, I need to first have either alternate interior, alternate exterior, or corresponding angles congruent. To get that, once I have the triangles are congruent, I can use CPCTC to state that, and then once I have that, I can state the lines are parallel. That's it. We'll go over one more, but there's nothing more to it. That's the concept. Number 2, I'm giving you that the triangles are congruent, but again, this is a mini proofs version. In a regular proof, you'll have to first prove the triangles are congruent. Or if you're watching this in preparation for the parallelogram proofs, it doesn't have to come from CPCTC. It can come from a given, it can come from anywhere, but the fact remains, in order to prove parallel, I need either alternate interior, alternate exterior, or corresponding angles to be congruent. So, I know that these triangles are congruent, so I can use CPCTC to state any of the corresponding parts are congruent. And ultimately, I want to get either alternate interior, alternate exterior, or corresponding angles to be congruent. Well, these are alternate exterior angles, and those are corresponding parts of those triangles. So I can state that angle SYC is congruent to angle NKA by CP/CTC. Since those triangles are congruent, then those corresponding angles must be congruent. And now, since those are alternate exterior angles, if the alternate exterior angles are congruent, then the lines must be parallel. CL is parallel to HA. Parallel lines cut by a transversal create congruent alternate exterior angles. And again, they're alternate exterior because they're both outside of the parallel lines. Both outside alternate exterior, both inside alternate interior, and when it's 1 and 1, like here, that would be corresponding. So that's it. In order to prove that lines are parallel, I need either alternate interior, alternate exterior, or corresponding angles to be congruent. Once I have that, then I can state the lines are parallel. And to get that, for the purposes of this lesson, we use CP/CTC once the triangles are congruent. But keep in mind, it could also come from a given. It can come from anywhere. Once you have alternate interior, alternate exterior, or corresponding angles congruent, then I can state the lines are parallel. Practice. See ya.